colorless liquid. In the practical, we don't write Rugambo. You have to be brief and precise. You have to be just on point. I've seen a colorless liquid, comma, tons, anhydrous. Anhydrous copper 2 sulfate, from what? From white solid to blue crystals. Sorry. Are you seeing this? In my observation, I don't give the name that this is water. I call it a colorless liquid, and I give a test for that colorless liquid. I say colorless liquid, comma, turns anhydrous copper 2 sulfate from white to blue. Now, when they are marking you, what are they going to mark? They are going to mark the colorless liquid you have talked about. And how then they are going to mark the substance you have identified, which is testing that colorless liquid, which is anhydrous copper 2 sulfate. Then they mark how is that substance changing. It is changing from white to blue. No.
No, you should be having anhydrous copper 2 sulfate on the side.
Yeah.
The one which you use.
Okay. So now, this is our observation. Now I want to come up with a deduction. Deduction is the conclusion. What will be the conclusion? What will be the conclusion? Okay, hydrated salt. But what is the name of this colorless liquid? So I'm going to write water of crystallization. So now I'm having a hydrated salt. You putting the word present or what, it is okay. But the main point which they will be marking is this and this. Water of crystallization. That's what we have seen. So I'm having a hydrated salt. Someone putting there present, it is okay. You understand? Now, I've talked about only this. I've not talked about the litmus paper changing and even the substance. You understand? Now, can you talk about the substance? Actually, I still... Now, we want to talk about the color change of the substance. What was the color change? Okay, it was from what to what? So I'm going to say blue solid, or blue crystals. So blue crystals turned. Blue crystals turned to what? To white solid. Now that is gentle heating. What we did was gentle heating. We didn't heat strongly. Now what Mr. is trying to do is to do stronger heating. Now when we do the stronger heating, it can change to what? To black. If you do overheating, it can decompose to what? To black. So blue crystals turned to white solid and then to black solid. Now that is very good. The space is not enough. Now when you are writing those things, I said you try to be a little bit brief. Don't add some other things which can just you take the space when you are missing out the key things. Then you still try to write some small things. You understand? Blue crystals turn to that. Now, what is the deduction? I want to make a conclusion on that one. I've given a conclusion on water of crystallization. Now I want to give a conclusion on this. What will be the conclusion? We are saying white crystals turn to white and then black. What will be the conclusion, the deduction?
No, you have already seen the observation.
Now you have to give a conclusion.
What do you conclude?
What is the conclusion? Okay, anyway, it's okay. Now the black substance. Okay, someone is giving theirs.
I'm sorry if I'm late there.
Ah.
Colorless liquid, we first talked about the times anhydrous copper 2 sulfate from white to blue. Are we talking about the presence of water, or we are talking about what we are producing?
Okay.
Are you talking about the presence of water, or you are talking about?
About what we are producing.
What from? When you hit this substance, it produces water. The water goes on the polar parts of the test tube. The teacher has told you that water, you don't know whether it is water. You're not sure. You have to confirm. How do you confirm that it is water? You get a drop of it and put it on dry copper 2 sulfate, which they have called anhydrous copper 2 sulfate. That copper 2 sulfate is white. When you put there a drop of water, it will become blue. Then you confirm that it is in water. So it is not in order. Let me use the parliamentary language to conclude that the colorless liquid is water unless you have done a confirmatory test.
And maybe another thing, maybe which can confuse you a bit, the substance we are testing is copper 2 sulfate. You understand? And the substance we use to test the colorless liquid you are talking about is also copper 2 sulfate. Maybe that is what it is confusing you. You understand?
White.
But I can.
I have been heating this to remove water. Now, what you are seeing here is a white substance. This is anhydrous copper 2 sulfate. So if we want to test whether the substance is water,
Some water.
if that is water,
I'm
if
sorry.
you want to test it to see whether this is water, you put a molecule of water here. It will turn blue. This is white. Yes, sir. It is hot. Stop.
You see? It has gone back to blue.
It has gone back to blue. Then this is the confirmatory test. That is what? Water turns the anhydrous copper 2 sulfate from white to blue.
Yeah. Okay. Yeah. So anyway, it's okay. So now, I want us to give a conclusion here on the substance. Yes.
Excuse me, sir. Now, like here, after strongly eating, when we are eating this copper 2 sulfate and we strongly heat it, what if we form that black solid that is the copper carbonate?
Okay, we don't form copper carbonate. Actually, if I'm having this. You understand? The substance which we are heating is this. This is the copper 2 sulfate. When you heat it, this water is going to be lost and you remain with only copper 2 sulfate. You understand? Which is white, the copper 2 sulfate without water. Then this one is having water, it is blue. Now, the blacker thing we are talking about is heating this one. When you heat this one, it breaks down and you form another substance which is called the copper 2 oxide, which is black. You understand? And actually, that is the conclusion I'm going to make here. I'm going to write the conclusion. It is the copper 2 oxide. Someone can put the word formed. Are you there? We are saying blue crystals turned to white solid and then black. What is the conclusion? I have formed the copper oxide. You understand? Then it means now the cation present is copper 2 ions. Because we are detecting. We didn't see black. Now the black thing, to get it, you have to do some strong heating. Strong, you heat it like for some good time. Okay. Now, number one, I've said in the practical, there are some things which you must be knowing. Are we together? Which you must be knowing. Now, for me, I'm telling you black because already I know. You understand? Now, to heat it strongly, to turn it to black, it will take some time. Number two, you have to apply some good heat. You understand? To change it to black, you can see he has tried to do the heating, but it has taken a lot of time to change, actually from blue to white. Then changing from white to black, it will also take some good time. You understand? But what you need to know is that this copper 2 sulfate, when you do the strong heating, it breaks down and form what you call the black copper 2 oxide.
Actually, I was trying to heat it strong. If you were observant, some small colors had started changing at the bottom, but it takes a lot of time. However, you know that it decomposes. So if heating continues and hydrous copper 2 sulfate undergoes decomposition from copper oxide, which is black in color.
Okay.
Is that clear?
So
this observation. Did you observe?
Our observation is this.
Turn to white and then the black solid. Yes.
So I'll be focusing on blue. That will be a mark, changing it to white and then to black. You understand? Now those are the marking points. Then the conclusion, they will mark the copper oxide you have talked about, and then the cation you are suspecting. It is also okay. Those other words you are adding in, it is okay, but they are not marked. So to gentle heating, it is okay, but they will be focusing on the blue and then the white and then the black. So those other words, that is the English you are putting in your observation. Yeah.
Key point C1. Those color changes. What was the mention is
okay.
We have not talked about the gas.
Now we have not talked about the gas yet. Now, which gas are we going to talk about? Sorry. Can I remove this? Let me remove this. Okay, now we are going to talk about the gas. Are we together? Number one, we have said we have actually most of the gases which we produce, they are acidic. For example, look at this. For example, I have sulfur dioxide. Are you there? I have sulfur trioxide. I have carbon dioxide. I have hydrogen chloride gas. All these gases, they turn a blue litmus paper to red. You understand? So, somehow, somewhere, you may not be able to make a final conclusion here. Why? Because you have very many gases which can change a blue litmus paper to red. Automatically, this paper will change from blue to red. But we don't know which gas. Now, you can confirm the gas, okay, you can talk about the gas after confirming the anion present. I don't know if you understand what I'm saying. Now, this is what I encourage for my students. Number one, the question of heating, the part of heating, it is the one which takes a lot of marks. Are you there? I'm saying the part of heating takes a lot of marks because you have very many things which you are supposed to talk about. You understand? For me, what I normally tell students, that it's better you start handling this part of heating after confirming the anion present and the cation. Like for example, I can do this paper. I can start doing other numbers, then other things before coming to heating. After doing everything here, I have confirmed that in this compound they have given me, it is sulfate. It is also a copper. You understand? You can be able to give correct observations on heating. I don't. You already know that in this compound there is a sulfate. So the gas I'm going to talk about is going to be sulfur dioxide. I'm going to give observations on sulfur dioxide because I've already confirmed. You understand? Mm-hmm. You are saying what? Oh. Okay, it's okay. Q, it's okay. If it is a Q, it's okay. But for me, what I'm saying, if you are in UNEB, are you there? It is better you first handle these numbers which don't require heating to be able to confirm a cation and the anion present. Then after, you come back and talk about the heating. After confirming, like for example, we are now discussing, I know the compound I've given you, it is a copper to sulfate. I can easily talk about the gas because I know when I heat that substance, I'm going to produce sulfur dioxide. You understand?